you're in year 11, this really is the very last video before the AS Pure exam. And this one is also for Sahisnu, and it's quite a tricky circle question with some coordinate geometry. Now, I did work solutions for it, but I want to do a video on it as well. The first thing we're told here is that we've got a circle C1, and it's got endpoints given to us. And we have to find an equation of the circle. Now, it's 3 marks, so you know that it's not going to be nothing. What you have to do this question is think back to when you first learned about all the words that went with circles. What is a diameter? Well, a diameter is from one side of the circle to the other, but it's not down here, right? The feature of the diameter is that it goes through the center of the circle. Now, it's pretty obvious when you think about it, but it's the key to doing this question. So we have to find the midpoint of the diameter. That's going to give me the center. And from there, I can pretty easily get the radius. So let's work with these 2 points we've got. So we've got -3, let's see, -3, -5, and then we've got 7, 3. So the midpoint is equal to, so -3 plus 7 over 2, -5 plus 3 over 2. And that gives me a midpoint of 2 and -1. Right, now, how can I get the radius? Well, the radius is half the length of the diameter. So let's figure out, let's use some Pythagoras to find that. So the radius is half this. So the distance formula, so it's going to be, which way am I going to go? -3 minus 7 squared plus -5 minus 3 squared. So that works out to be the square root of, so this is -10. -10 squared is 100. And this is -8. So it's not going to be a very nice number, which is, that gives me 1/2 of root 164. You can see that there's a factor of 4 in here. So taking that through the third sign, we get 1/2 times 2 root 41. Right, so r is equal to root 41, and r squared is equal to 41. Now that means that I can get the equation of the circle now, because I know the center of the circle and I know the radius. So my format for the equation of a circle is this: x minus a squared plus y minus b squared is equal to c squared, when the center is at AB and the radius is c. So in this case, that gives me an equation of the circle, which is x minus 2 squared plus y plus 1 squared is equal to 41. So that's the first part of that question done. Okay, let's go back up and see what happens to the circle next. It's very exciting. Right, the circle is translated by a vector 8, 4, right? So it goes along 8 in the direction of the x-axis, and then it goes up 4 in the direction of the y-axis to give this second circle. So now, since we've got the equation of the circle in nice, obviously giving me the center form, all I have to do is to change the coordinates of the center. So the center was at 2, -1, and now the center is going to be at 10. Oh, why is it doing that? So the center is translated, right? All of the points are translated, including the center. So the center is now going to be at 10, 3. And that means that the new equation is going to have those in it, right? So new circle, C2, will be this equation: x minus 10 squared plus y minus 3 squared. And the radius hasn't changed, right? So the circle hasn't grown, it's just a translation. So that was pretty easy, 2 marks. Now, next bit. The 2 circles intersect at points R and S. So we have to show that the equation of the line RS is this. Well, let's look at how we're going to find points R and S. R and S are sitting on both of those circles. So we're going to solve simultaneously those 2 circle equations. And we're going to end up, once we do that, we're going to have a little bit of algebra to do here, but then the equation linking them is going to fall out. Right, so finding points R and S. Well, we've got x minus 2 squared plus y plus 1 squared equals 41. And we've got x minus 10 squared plus y minus 3 squared. And that also equals 41. So that means that this has to equal this, because they both equal to 41. So I have to expand a couple of quadratics and then simplify. Okay, so now I'm just expanding everything out. X squared minus 4x plus 4 plus y squared plus 2y plus 1 is equal to x squared minus 20x plus 100 plus y squared minus 6y plus 9. Now there are a few things that we can knock out straight away. So the x squareds can both be subtracted, and the same with the y squareds. So now what do I have? Well, I've got negative 4x plus 2y plus 5 is equal to negative 20x minus 6y plus 109. Let's gather everything over to one side. So I'm going to add all of this stuff over to here. I get 16x plus 8y minus 104 equals 0. Now, if you're doing this in the exam, it's well worth checking you're working as you go, because if you've mucked this up, it's going to be pretty frustrating when you get to the end, because we know that we're kind of following a logical approach here, but it's still easy to make small algebraic errors. So looking here, we want to end up getting y equals negative 2x plus 13, and you can see that we're just about there, just by trying to find the 2 points. All right. So what have I got to do now? Well, I've got 8y is equal to negative 16x plus 104, and I can divide through by 8. So y is equal to negative 2x plus 24, plus 13. Okay, so we're done. Now, the other way that I could have done this is that I could have said, going back up to the picture and using the diagram, that we know we can find these 2 points because, and I'll put the ruler on to show this. This is actually how, when I was at school, this is how you learnt to construct circles, kind of, with a compass and all this stuff. So if we take that and then we think about our 2 centres, that RS line is the perpendicular bisector of the line that joins the 2 centres. Right, so that's actually a faster way to do this question if you're confident with that idea. Right, so we've got this point here and we've got this point here, and RS is the perpendicular bisector of the line from here to here. I've done that way in the worked solutions. I'm not going to work through it now. It'll get you to the same point. So then the last thing that we have to do, we've found this. So now we have to show that the x coordinates of R and S satisfy this equation. So we're told that we've got y equals negative 2x plus 13. And we can see that R and S are on both the circles. So we can choose either circle equation to substitute this y value into. Okay, so I'm going to do the one with 10, like the second equation here. I'm going to take that equation and I'm going to sub in the y value. So that's giving me all of the points on that C2 circle, and I want the ones with R and S. So I know that RS has got this equation, y equals negative 2x plus 13. So I can sub that in. So x minus 10 squared plus negative 2x plus 13 minus 3 squared is equal to 41. Right, so I get x squared minus 20x plus 100 plus 10 minus 2x squared is equal to 41. X squared minus 20x plus 100 plus 100 minus 40x plus 4x squared is equal to 41. Right, let's combine some terms here. And it's starting to look really good. We've got 5x squared minus 60x plus 200 equals 41. And when we subtract the 41, we get exactly what we wanted. So there you go. So Hisnu, hopefully that helps a wee bit. It is quite a weird question. You've got to have a pretty good understanding of the equation of a circle and also be quite confident with all of that, expanding the quadratics and not losing any little numbers here and there. Hopefully that sorts things out. So I will leave it here, and good luck for tomorrow, everyone, if anyone's still watching after 11 whole minutes.